Installing a ground rod at sub-feed boxes is generally not recommended. The grounding system is usually established at the service entrance, and duplicating it at sub-feed locations can create ground loops and other electrical hazards. If there's no mechanical ground from the main service entrance to the sub-feed boxes, establishing a proper grounding system within the auditorium becomes crucial. This involves installing a grounding electrode system, or GES, which typically includes one or more ground rods driven into the earth and connected to the electrical system. Maintaining separation of ground and neutral is important throughout the electrical system, including the lighting booth. This prevents current flow through the ground wire, which can be hazardous and interfere with equipment operation. A recommended solution involves firstly, installing a grounding electrode system in the auditorium, which provides a proper grounding reference for the electrical system, protecting against electrical hazards. Secondly, connecting the ground wire from the grounding electrode system to the grounding bus in the lighting booth, providing a common ground for all equipment in the booth. And thirdly, ensuring the ground and neutral are separated throughout the electrical system, including circuits run to the stage for audio gadgets. The size and type of grounding electrode system required will depend on the size and configuration of the auditorium. Consulting a qualified electrician for design and installation is highly recommended. Regular maintenance and inspection of the grounding system is essential to ensure its proper functioning. Additional information regarding grounding electrode systems can be found in the National Electrical Code, specifically Article 250. Firstly, let's discuss grounding electrodes in more detail. According to the NEC, grounding electrodes must be installed to ensure a low impedance path to ground, facilitating the operation of overcurrent devices and limiting voltage on equipment enclosures. Acceptable grounding electrodes include metal underground water pipes, metal frames of buildings or structures, concrete encased electrodes, ground rings, and ground rods or pipes. When using ground rods or pipes, they must be at least 8 feet long and driven at least 8 feet into the earth. The upper end must be flush with or below ground level unless protected against physical damage. If rock bottom is encountered, the ground rod can be buried in a trench at least 30 inches deep. Secondly, let's delve into the concept of ground loops. Ground loops occur when there are multiple paths to ground, creating a loop in the grounding system. This can cause unwanted current to flow through the ground wires, leading to noise and interference in audio and video equipment. Ground loops can also pose a safety hazard, as they can cause equipment enclosures to become energized. To prevent ground loops, it is important to ensure that there is only one path to ground for each piece of equipment. This can be achieved by using a single-point grounding system where all equipment is grounded to a common grounding point. Thirdly, let's discuss the separation of ground and neutral. The neutral conductor is the return path for current in an electrical circuit, while the ground conductor is a safety conductor that provides a path for fault current to flow back to the source. In normal operation, the neutral conductor carries current, while the ground conductor does not. However, in the event of a fault, the ground conductor provides a low impedance path for fault current to flow back to the source, tripping the overcurrent device and energizing the circuit. It is important to keep the ground and neutral conductors separate throughout the electrical system to prevent current from flowing through the ground wire. This can be achieved by using separate conductors for ground and neutral and by avoiding any connections between the two conductors except at the service entrance. Fourthly, let's talk about the grounding bus. The grounding bus is a conductive bar that serves as a common grounding point for all equipment in a panel board or enclosure. The grounding bus is connected to the grounding electrode system, providing a path for fault current to flow back to the source. All equipment grounding conductors in the panel board or enclosure must be connected to the grounding bus. This ensures that all equipment is properly grounded and that fault current will flow back to the source in the event of a fault. Fifthly, let's discuss the importance of consulting a qualified electrician. Electrical work can be dangerous, and it is important to consult with a qualified electrician for the design and installation of any electrical system. A qualified electrician has the knowledge, skills, and experience to ensure that the electrical system is installed safely and in accordance with all applicable codes and regulations. They can also help you select the appropriate grounding electrode system for your specific application and ensure that it is properly installed. Sixthly, let's consider the NEC requirements for grounding and bonding. The NEC provides detailed requirements for grounding and bonding electrical systems to ensure safety. Article 250 covers grounding and bonding requirements, including the types of grounding electrodes that are permitted, the size of grounding conductors, and the methods for bonding metal enclosures. It is important to be familiar with the NEC requirements for grounding and bonding before performing any electrical work. Seventhly, let's touch on the topic of regular maintenance and inspection. Regular maintenance and inspection of the grounding system is essential to ensure its proper functioning. This includes visually inspecting the grounding electrodes and conductors for damage or corrosion, as well as testing the grounding system to ensure that it is providing a low impedance path to ground. Any problems with the grounding system should be corrected immediately to prevent electrical hazards. Eighthly, let's discuss the specific requirements for grounding in an auditorium. An auditorium can be a challenging environment for electrical grounding due to the presence of sensitive electronic equipment such as sound systems, lighting control systems, and computers. It is important to provide a clean and stable ground for this equipment to prevent noise and interference. This can be achieved by using a dedicated grounding system for the auditorium, separate from the building's main grounding system. The dedicated grounding system should be connected to a grounding electrode system that is specifically designed for sensitive electronic equipment. The grounding electrode system should consist of multiple ground rods or plates that are interconnected to provide a low impedance path to ground. Ninthly, let's consider the grounding of audio equipment. Audio equipment is particularly susceptible to noise and interference from ground loops and other grounding problems. It is important to ground audio equipment properly to prevent these problems. This can be achieved by using shielded cables, isolating transformers, and ground lift adapters. Shielded cables help to prevent noise from entering the audio signal. Isolating transformers break the ground loop by isolating the audio signal from the ground. Ground lift adapters allow you to disconnect the ground connection on a piece of audio equipment. However, it is important to use ground lift adapters with caution, as they can create a safety hazard if not used properly. Tenthly, let's discuss the importance of proper bonding. Bonding is the process of connecting all metal enclosures and equipment together to form a continuous electrical path. This helps to ensure that all metal parts are at the same potential, reducing the risk of electric shock. Bonding is particularly important in an auditorium where there are many metal enclosures and equipment that can become energized in the event of a fault. All metal enclosures and equipment in the auditorium should be bonded together using bonding jumpers or other approved methods. The bonding jumpers should be sized according to the requirements of the NEC. The National Electrical Code Section 250.50 covers grounding electrode systems, emphasizing the interconnection of all available electrodes to form a unified grounding system. This typically includes metal water pipes, the metal frame of the building, and concrete encased electrodes. Section 250.52 details the specific requirements for each type of grounding electrode, including the minimum size and installation depth for ground rods and pipes. Section 250.53 outlines the methods for grounding electrode conductor connections, ensuring that the connection is mechanically sound and electrically conductive. Section 250.64 covers the requirements for grounding electrode conductors, including their size, material, and protection. Section 250.66 provides guidance on the size of the grounding electrode conductor for alternating current systems, based on the size of the service entrance conductors. Section 250.104 discusses bonding of piping systems and exposed structural metal, ensuring that these metal components are bonded to the grounding electrode system. Section 250.118 lists the acceptable types of equipment grounding conductors, including wire, cable, and busbars. Section 250.122 provides guidance on the size of equipment grounding conductors based on the rating of the overcurrent protective device. Section 314.4 covers the use of non-metallic boxes, which requires special attention to grounding to ensure that equipment is properly grounded. When dealing with older buildings, it's crucial to inspect the existing electrical system thoroughly. The age of the wiring can impact its insulation and conductivity, potentially affecting grounding performance. In older systems, the grounding conductor might be undersized or even non-existent, necessitating a complete overhaul to meet current safety standards. Evaluate the existing service entrance. Determine if it's adequately sized for the current load and future expansion. Upgrading the service entrance may be necessary to accommodate the increased power demands of modern sound and lighting equipment. Address any existing code violations. Correcting code violations is essential to ensure the safety of the electrical system and prevent potential hazards. Consult with a qualified electrical inspector to identify any code violations and develop a plan for correcting them. Consider the use of isolated ground receptacles. Isolated ground receptacles provide a separate grounding path for sensitive electronic equipment, reducing noise and interference. These receptacles are often used in recording studios and other environments where clean power is essential. Install surge protection devices. Surge protection devices protect electronic equipment from voltage surges which can damage or destroy sensitive components. Surge protection devices should be installed at the service entrance and at each piece of equipment. Use high-quality cables and connectors. High-quality cables and connectors are essential for ensuring reliable performance of audio and video equipment. Use cables and connectors that are specifically designed for the intended application and that meet industry standards. Label all circuits and equipment clearly. Clear labeling helps to prevent confusion and makes it easier to troubleshoot problems. Label all circuits and equipment with their function and voltage. Document the electrical system thoroughly. Thorough documentation provides a record of the electrical system and makes it easier to maintain and troubleshoot. Document the location of all circuits, equipment, and grounding points. Include wiring diagrams and other relevant information. Train staff on electrical safety. Training staff on electrical safety helps to prevent accidents and injuries. Train staff on the proper use of electrical equipment and the hazards of electricity. Emphasize the importance of following safety procedures and wearing appropriate personal protective equipment. Conduct regular inspections of the electrical system. Regular inspections help to identify potential problems before they become serious. Inspect the electrical system for signs of damage, wear, or corrosion. Test the grounding system to ensure that it is providing a low impedance path to ground. Document all inspections and repairs. Keep a record of all inspections and repairs. This helps to track the condition of the electrical system and identify any recurring problems. Consult with a qualified electrical engineer for complex grounding issues. A qualified electrical engineer can provide expert guidance on complex grounding issues and help you design a safe and effective grounding system. They can also perform calculations to ensure that the grounding system meets all applicable codes and regulations. Remember that grounding is not just about safety, it's also about performance. A well-designed grounding system can improve the performance of audio and video equipment by reducing noise and interference. In summary, when dealing with grounding issues in an auditorium sound system, remember the following key points. Firstly, avoid installing ground rods at subfeed boxes. Secondly, establish a proper grounding electrode system in the auditorium. Thirdly, maintain separation of ground and neutral. Fourthly, connect the grounding electrode system to the grounding bus in the lighting booth. Fifthly, consult with a qualified electrician for design and installation. Sixthly, regularly inspect and maintain the grounding system. Seventhly, consider the specific requirements for grounding in an auditorium. Eighthly, ground audio equipment properly. Ninthly, ensure proper bonding of metal enclosures and equipment. Tenthly, document the electrical system thoroughly.